Video shows the breakup of Pine Island Glacier. The bottom of the ocean is sinking, warping and deforming because of the added water weight from melting glaciers. What does this say about estimated extent of sea level rise? Pixabay melting glaciers have long been linked to rising sea levels, but the melting ice has also added so much water to the world's ocean that the seabed now sinks underneath the increasing weight. Ocean floor sinking, warping, and deforming. The enormous mass being added into the ocean also causes the seafloor to warp and deform, and this can disguise the actual rise of sea levels in some parts of our planet and even cover up the actual extent of sea level rise. A new study published in Geophysical Research Levels, study researcher Thomas Fredriksen from the Delft University of Technology in the Netherlands, and colleagues use a mathematical equation called the elastic sea level equation to get a more accurate measurement of the ocean floor. Their calculations allow the researchers to see the extent to which the bottom of the ocean floor has changed over the last 2 decades. The study is the first to take into account how the additional water from melting ice have stretched the bottom of the ocean. We have had tide gauge sea level rise measurements for more than a century, Fredriksen said. You put an instrument at the sea bottom and see how far sea level changes relative to the bottom. Satellites orbiting the Earth measure sea level from space. We wanted to see how large is the difference. Extent of sea level rise may be underestimated. Calculations revealed that between 1993 and 2014, the rise in the total ocean load caused the seabed to sink by about 2.5 millimeters, or about 0.13 millimeters per year. Sagging of the ocean floor in some regions, however, is significantly greater, with as much as 1 millimeter per year in the Arctic Ocean and 0.4 millimeters in the South Pacific. The findings could mean that satellite assessments of changes in sea levels, which do not take into account the sinking ocean bottom, may be underestimating the extent at which seas are rising. The barostatic sea level rise, the actual increasing volume of the ocean, in particular, is masked from measurements that are based on satellite observations. Over 19,932,014, the resulting globally average geocentric sea level change is 8% smaller than the barostatic contribution, the researchers wrote in their study. Over the altimetry domain, the difference is about 5%, and due to this effect, barostatic sea level rise will be underestimated by more than 0.1 mmYr over 19,932,014. Researchers said that the accuracy of future estimates of sea levels can be improved if the sinking of the ocean floor is accounted for. Ocean floor, melting glaciers, rising sea levels. Copyright 2018 Tech Times, all rights reserved. Do not reproduce without permission.